guys, let's resume the lecture. So we are talking about structuring your logic, and we said that you can structure your logic if you know these three basic building blocks: sequence, selection, and decision, and the loops, which we have on this slide. So sequence, selection, and loop. If you know these three, how to draw them on a flow chart, then you will be able to communicate your findings, your logic with your friends and with the client. Okay. So if you look on this flow chart, now in the case of loop, we need to make decision on certain variable. But over here, the entry point itself loop condition. So we need to initialize a variable, but that is not being represented as part of this flow chart. Okay. So we need some input, and we need to take that input so that we are able to check the condition. So that reading of input so that loop can iterate, can basically make decision on the variable is called as priming read. Okay. So priming read is something we are taking in some information in a variable outside of the body of this structure, which we call it as a loop, in order to trigger the loop condition. Okay. So in flow chart, that is not part of the loop itself. That is outside of the loop. Okay. So we call it as a priming read. Okay. So that's why always analyze your program step by step. You need to identify the loop, and the priming read should be outside of the loop. Okay. So this is one thing. And it's a good practice when you're doing coding. You code a line, try to see if there is error or not. It's not like that you keep on coding 10 lines of code and then try to identify the error. And then debugging the program becomes very difficult. So in summary, we need to look for structure within a program, and we have to ask few questions whenever we draw these flowchart structures, whether they adhere to the rules which we learned on previous slide. And these are the rules. Question has been asked, some instruction has been processed, and in case of loop, does it go back and ask question again? So this is one example, and it has been mentioned over here that this program is structured, that it is following certain rules. This program is structured, this program is following the rules which we discussed before, but it's non-functional. Why it is non-functional? What do you think? What is the issue with this logic being drawn as a flow chart?
Coming back after you input a number.
It's coming back?
So you input a number and it doesn't work, but it's going back after you input the original number.
Yeah, so you're not asking for input again. So it will be infinite loop, isn't it? So you're not asking for that variable again. But structure is fine. It's asking for condition, some instructions, and loops go back again to where question is being asked. That's fine. But there's some flaw with the logic over here. Okay. So this is the issue. Okay. So what is issue over here? Now this is functional. This is functional, this will work. Just look at it. But it's not structural. It does not follow the rules which we discussed before. And what is that?
You can input once again.
No. Regarding structure. Functionally is fine. Functionally this will work. But what is the issue with the structure? Remember, loop has some entry condition and exit condition. The loop arrow back should go to where question is being asked. So in this case, is going beyond the primary read. So this should be over here rather than over there. So this is structural issue over here. Okay. Logic is fine. You implement, it will run. It will give you the functionality. But from flowchart point of view, this is structural error. Okay. What about this one? Does it address all the concern? It is structural. Yes, we have loop, condition, some instruction we execute, and the arrow goes back again to the entry point of that loop, which is the condition itself. Okay, and to make it functional, because input is outside of this loop, which is priming read, we asked for input again over here. Now it's functional. So you can see that it's not about making your program functional. It's also about structure. It should be structured, it should follow structural rule, and it should be functional as well. And this is the objective we want to achieve when we draw flowcharts. What is the issue with this program? The issue is quite serious. Yep. Speak loud.
It's difficult to interpret.
It's difficult to interpret. Why?
Just it doesn't finish like not E off.
Okay. End of file. Okay. But other than him, anyone wants to say something? What's the issue over here?
You haven't got any input to text.
Pardon?
You haven't got any input to text.
Okay, but input is over here. Primary read is fine. There should be a primary read. That one thing. That should be there. But what's the functional issue over here? So you are taking input over here. And if user enter end of file, still your loop will go through all these instructions and then go back. Okay. So again, as a fellow student mentioned, priming input is missing. Okay. And this input should not be over here. It should be after this. So you see that the thing which you put on the paper, it has meaning, which would be understood by your team member. So you have to be explicit. You should not take assumptions into account. So reason for structure, we need clarity in the program so that we can understand it and we can share it with friends. And program should not be confusing. We discussed before that once the software goes in production, it is being used by industry, then it's very hard to change things. Professionalism. In every industry, we need professionals. And professionals have a way of doing things. So in software also we need a professionalism. That especially if you look at the open source code, most of the open source code you will find they are well documented. Okay, because these are the people who are not getting any money to code their program, but they are professionals. They love programming. They love sharing their code, and they comment it very well. Okay. Efficiency, we all know the object programming languages, they are efficient if you design your code following their rules. Okay. For example, threads. If you make use of multi-core functional processors, threading is a good option. Maintenance easy, modularity, again it helps you understanding the concept, and depending upon languages, efficiency also increase. So these are some reasons for which we are talking about structure. Okay, these are the advantages which we get. So these are structure flow charts. What do you think? Is there any issue with these flow charts? So this is sequence, then this is selection. If else, that's fine. This is again decision, but this decision arrow is coming back, so it's a loop, and loop have some if condition in it. If have something is true, this will happen. No else is there, and then it goes back to the question. So structurally, they look fine. Another unstructured flow chart, and what is the issue? I'm sure you can point it now quickly. Now this else is going in else of another if. Okay. So this is issue over here. This is not structure. As I mentioned before, the lines should not be crossing over. They should not be touching in this fashion. So this is issue over here. So how you will basically avoid this situation? So whenever you start your program, basically identify the important constructs you need to start it, and then do the stacking of your controls which you want to use. And if this situation comes where you have some condition, and on the basis of that condition you take into account another criteria for decision making, and if that decision is false, instead of going back to the main if and calling that else, you should basically write its else. And this is not a modular call. These signs does not represent module. Again, I want to highlight over here. So this way we can overcome the situation. No matter it is calling the same line, same instruction, but you have to repeat it for clarity on your flow chart. Okay, so if you follow this approach, then you will end up in a flow chart that will have well-defined meaning, following the rules and regulations. Okay, we should avoid this situation. Okay, now let's come back to the example which we saw before. Now we have to recognize the structure. We have to appreciate the structure in a program. While doing it, we have to be critical of our work and see critically that whether we are following the structural rules or not. So this is how we start. So we start a program. We have some instructions to catch the dog, and after that we have this loop which says that if dogs run away, go and catch it again. So it goes back again to the question. We have primary need over here. So loop is over here. Loop follows the rules which we discuss. So everything is fine. What is the issue over here? Can you spot the issue? Again, following the structural rules.
It asks, does it run away a couple of times? Same sort of question.
So those are repetition. That's fine. We will address this later on. Okay. So what we have done, we have, if dog does not run away, we open the tab and we check again whether dog is still there. If it is not, we turn off the tab and we go and catch the dog. And then we are going back to the decision.
Seems maybe redundant to have it go back to the very top instead of just before maybe to turn water on.
Turn around here. There's something issue with this. It should not be going back over here. Where it should go? Over here. Because this loop started over here. Okay. So logically your logic would be fine. You want to go back and ensure that you catch the dog, but this is the where loop started. So this is the entry condition. You have to go back to entry condition. Okay. So that's the issue over here. So in order to address that, what we did, so we turn off the water, turn off the tab, then we catch the dog, because from here we cannot go to another loop. Okay, so we have to code something over here. And now we are recognizing the structure in the program. Okay, by following the rules, we are bringing structure into our program. And we have put one loop over here. Okay, so that if the dog run away, go and catch it again. And this loop is work. And turn on the water, and this is the external loop. So we have internal loop and external loop, and this follows the rule. So if you keep on building your logic and you adhere to the rules, you will come up with this logic, and you will see that there are repetitions. We are catching a dog over here, we are catching a dog over here, we are catching the dog over here. But this flow chart adheres to the rules which we discussed before. We are not in condition where we are doing this. Okay, we are following the rules and we came up with this solution. Okay. Now we can see that there are certain iterations, there are a set of instructions that are repeated exactly. So what does it tell? We need to create a module in a program. So there are a set of instructions that are being copied exactly in different part of the flow chart. And this basically led you to identify structure, another structure which is, we call them module, function, subroutine, depending upon the language. Okay. This example is simple. Thus, it may look to you, we should have done this before, but when you're working on complex enterprise level applications, then you basically have to go through this process in order to identify those structures. So now what we did, we created a subroutine, we created a function, and subroutine is represented as highlighted on this slide. And wherever we need that functionality, we need that function, we can call that function. Okay, and we define that function somewhere on the flow chart, and this is how we define them. Okay, you got the point? So while you are designing your logic on using flow chart, you need to follow the rules, and by doing that, you will identify structure in your program. You will identify that, okay, this is something I need to address now. Especially in this case, we are talking about function. So in this case, a more modularized version of the washing the dog. So that was regarding flow charts, and we see that this is a small scale example we discussed, but when things are very complex, then there are more rules which basically team member decides among themselves that needs to be followed. Okay, so these are very basic rules. But when logic becomes very complex, then team itself decide new rules and regulations that need to be enforced in order to model the complex logics. If you heard of data beans, DAO beans, those are the classes that basically exactly represent the database in memory representation. But anyways, so we have another special structures. So those structures were regarding designing flowcharts. Regarding programming logic, we have structures that can help us to represent those flowchart constructs into programming language. And one of them is case statement. Have you used case statement? Switch statement? Which language? C++. Yeah, in almost every language. It's either we call it switch or case. Case thing. Then we have do while loop and do until. Beside this, we have for loop, for each loop which you will use in the lab, and so on. So in the case of case structure, what we do, we have to make a decision against one variable, and we have multiple choices depending upon value of that variable. Okay, let me show this example. Now, depending upon a class that we have, whether it's fisherman, whether it's junior or whatever, we make a decision. But these values basically are assigned to a variable which is class. We have one variable, and depending upon the value of that variable, we have many choices. We can do this, we can set the tuition fee 75, we can set it 50, we can set it 30, or we can set it 10. So if and else statement can be used to address this scenario. But as the structure becomes very complex, it's difficult to modify the structure. Okay, the solution is provided in the, with this case structure. And what it does, basically, you take a decision. Now let me show you case statement. It's over here. So this structure basically allows you to look at the value of a variable and define different choices, different cases you want to be catered in your program. If the value is fisherman, then you can set the value of fisherman. So this is not complex structure. It's very easy. Case, if value is this, do this. A set of, it could be a sequence of instructions. If case is this, do this. Case is this, do this. And if none of these values exist and there's some else value, then take into account default, which is 10. Okay. So case structure provides you to handle, instead of using complex if-else structures, you can address those scenarios quite easily. And this is how in flowchart you can represent it. So in case of do while, so do while is a loop which is again available in all languages. And as I asked you before, in do while, and mentioned by one of our students, in do while we don't check the condition first. What we do, we execute some instructions first, then we go check the condition. Can you think of any real world scenario where we need do while loop? Where you don't check the condition first. You let the person do something, and then check the condition. I'm thinking as well. Real life, very simple example is washing hands. Okay, you let the person enter the washroom to wash his hand, and then check the condition, hands are clean or not. Especially if you do some pop-ups basically appear for chat. So again, chat is a loop situation. So they ask you, this is our information. Are you interested? Provide your login details, for example. And if you provide them, then they let you into the system. So in short, they provide you certain instructions to guide you that this is what will happen. Do you want to continue or not? Then condition is checked whether the user still wants to continue or not. Okay, so we do need do while in certain situations. So in this case, these instructions will get executed first, and then condition will be checked. And as I mentioned in VB.NET, we have another variant of this, which is do until. Okay. So in do while, as long as condition is true, for example over here, As long as variable is less than 20, the body will keep on executing. Okay, it will keep on running. In case of do until this situation is false. Okay, until this is false, keep on doing. So this is again different way, convenient for programmer if it helps them to build their logic. Okay, so this is specific to VB.NET case. So selection of the structure is up to the programmer. It's up to the developer. Okay, so how he basically can realize the functionality in order to achieve the objective. But we have to be very consistent, whether we are implementing the logic or we are designing the flowchart. We have to follow certain symmetry so that the semantics which are defined on one slide, on one web page, or in one program, they should be reflected in other cases as well. And it's a good practice if you have complex if-else structure, always start with the if. Maybe you don't need else. Okay, so this is one common practice. Now, in loops, as I mentioned, loops start with a condition. Entry condition is the condition itself, where we are testing the variables, and then we go to the body. So primary values are very important. That basically important for loop to check the condition. Depending upon business logic, we need to identify the looping structure. So we use for loop when we know what is the starting value, what is the starting value of variable, and what is the ending value. We use do while when we don't know whether this will run or not, but we want to execute it at least once. And we use while as long as condition is true, keep on executing. We don't know when it will end. Okay, so depending on the scenario, we use it. Now, if you're creating a program which summarizes sales of certain organizations, then you know that you have to iterate over 365 days. Your business logic, you don't need to basically go and try to understand how many times it will execute, or you don't need to use while loop because you know the termination point. But in certain cases, this is not the case, especially this form and your assessment one, where we have a form which has multiple fields and we don't know how many fields will get filled by the user, and we need to iterate over these fields. So we don't know whether it will be 1, 2, 3, 4, and 5. So in this case, we need some way to figure out how many times our loop needs to be iterated. First of all, do we need loop over here? So through this form, user will provide some information, name, ID, and so on, and then how many units student has taken, and that information will fill in. So for which part of this web form, in order to process it, we may need a loop. Is it the top part or bottom part? Bottom part, because we have values that are being repeated. Unit is being repeated, credit points are being repeated, year, and so on. So these are the fields which we need to repeat on. Okay, so you cannot hard code it. So at runtime, when this form is submitted, you have to calculate using your code how many fields are there. Okay, so you need to read the values. When form is submitted to your code, you need to read the values, and accordingly you need to identify how many times your loop need to iterate. Okay, again, this is pseudocode and it's more looks like a VB.NET, but in the workshop and in the some examples which I provided you, they are in C#. Okay, so one way is we basically count all the items that are on the form. Each input field is basically an item. The submit button itself is an item. When we submit a form, submit button is not over here, but when they submit a button over here and information goes to the next page, on the next page basically what we have all these fields represented as an item, in this case accessible to your code. Okay, so we iterate through all the item which we received from previous page, including text field as well as button, because button is also an item. Then we count how many fields are over there. By counting them, we can identify, okay, there are 4 fields on the top, and in every column there are 4 fields. So if we remove these 4 fields, we skip first 4 fields, and we divide rest of the number of fields, we can get the number of rows. Okay. Okay, you got the point? I will show you a code in a minute. So what you need to do is you need to calculate number of fields, and we know that top 4 fields we don't need to count in. So what you can do, you can add a if structure that if the field is this, then skip that one. In that case, don't increment the variable. Okay. So in this and as mentioned, you can divide it by 4, and you can get the number of rows that you need to iterate. Let me show you a code first, which is uploaded on the Blackboard website. So on your Blackboard website, I have provided 2 codes. This is for each loop, and this is for each code with validation. And if I'm not wrong, I have downloaded over here. So I'm opening the second one, which does have validation as well. Okay. So whatever we discussed on this slide is being coded over here. Okay. And by the way, if you copy paste code from the workshop document into your Visual Studio and it does not show coloring scheme, then what you can do, you can save your file, close the file, and reopen it. Then it will show you the coloring scheme of your code. But anyways, this is the web form. Okay, if you look over here, this web form has this form tag. Whatever we define within the form tag, that information would be submitted to the next page. Okay, so you can see this is a starting tag of the form, and this is the ending tag of the form. So whatever we define within these form tags, the controls that are defined within these 2 tags, their information will be submitted. As you can see over here, we have input name this, type this, ID this, and so on. Okay. Let me run this solution and show it to you. And this is exactly what you need to do in your first assessment. Okay. The logic is similar. That will be a little bit complex, but similar. For example, customer is Jinjua, I am ECU, product A, 10 items, product B, 20 items. Okay. And if I submit it, will go so. My laptop is a little bit slow. Okay, so what we got over here, it calculates that there are 23 fields on the form, text fields and the button as well. Okay, so and then it calculates how many fields I need to process. It displays the fields that contains the information, and then it shows error messages that product ID is missing for row 3, product quantity is missing for row 3, and so on. Okay. Let me take you the code. So when I submit this form, all the values that are in the field, they are received on this web page. Okay, I define variable over here, and this is for each loop that is available in .NET. So request.form is an object that is carrying all the values of the controls that were within the form tags. Okay, so by using this loop, I am iterating over them, and I count the total number of controls that are being submitted on the previous field, and I display them. And I know that 3 controls I don't need, especially the company name and what was the second one? The top 2 fields and the button. I don't need them, so I remove them from the count. And I know that in each row I have 2 controls, so I divide it by 2. And now this will give me the number of rows I need to iterate. Okay. So here's some validation over here. Again, comments are provided, so you can go through this code later on. So over here I'm iterating over the fields, and what I have done, now I know how many rows are there. So that calculation which I showed you on the top, I know how many rows are there, and I'm starting from I is equal to 1 because I'm skipping first row, which is a last name and the company. I'm skipping those 2 fields. And in this fashion, what I am doing, I am dynamically accessing the object. So if you look at the naming scheme that is given to those controls, every product field starts with product ID, and then I am concatenating I over here. So on previous form, there is a field that has name product ID 1, product ID 2, product ID 3, product ID 4, 5, 6, 7, 8, 9, 10. So I'm using this scheme, concatenation of I over here. It returns me, it will first of all access that object and return me value of that object, and I can save that in this variable. Similarly, I am accessing the quantity variable, and then there's some validation over here. If information is missing, it will display the message. Otherwise, it will display the information which is being submitted by the previous form. Okay, so go through this code, try to understand it, and similar logic you need to apply in your assessment 1. So in assessment, you need to do the coding in ASP.NET using VB.NET or C#, and also you need to develop the same logic in PHP as well. So all the workshops which you do from today onward till week 5, you will do the programming in PHP as well. Okay, so there will be no difference except the syntax. And PHP is very much similar to C#, but if you're using VB.NET, then syntax would be a little bit different as well. Okay, so primary reads are very important when you are reading information from the forms. Okay, you need to check their values, whether those controls have some value or not, because if you feed in null value to the loop will not work. It will give you an error. Okay, so sorry for this link was broken. I checked it today morning. So this is the link where you can read this article. Again, this will not be included in your exam. Okay, so this is just for fun. You can look at this article, which tells you the way how to write unmaintainable code. Okay. Even if you Google this one, you will find this article. It has been available on many web forums. So that's it for today. Do you have any question? How many of you have started work, or maybe looked at the assessment? Read the brief, assessment brief. Read it? So any concern? Any concern, question? No at the moment? That's good. But if you have, drop me an email, okay? Or share, post it on the discussion board. Okay, then I will see you in the lab. Thank you very much.